You ever stop and think how these huge companies manage thousands of servers, networks, and databases all over the world without it all turning into chaos? Well, I'll tell you one thing. They're not clicking around in web consoles. They're writing code. And more specifically, they're using tools like Terraform, which lets you build your entire cloud infrastructure from a single powerful blueprint.
So that's the big question, isn't it? If someone tasked you with building a complex cloud environment from the ground up, how would you do it? And maybe more importantly, how would you do it again, exactly the same way, tomorrow or the day after that?
You've basically got two paths you can go down. The manual way, man, that's a maze of clicks in a web browser. It's slow, it's super prone to human error, and it's nearly impossible to replicate perfectly. Then there's the Terraform way. Infrastructure is code. You just write down what you want, and Terraform goes and builds it. It's consistent, it's repeatable, and your entire setup is documented right there in the code. It's your living blueprint. Okay, so to really get how this all works, we need to start with the fundamentals. Let's break down the three core building blocks that honestly make everything in Terraform possible. This quote just nails it, doesn't it? You're not just writing some documentation, you're writing simple, human-readable configuration files that Terraform translates directly into active servers, databases, and networks that are actually running in the cloud. It's a really powerful idea when you think about it.
So, how does Terraform talk to all these different services? It does it through providers. The easiest way to think of a provider is as a translator. The AWS provider knows how to speak the AWS API. The Docker provider knows how to speak the Docker API. You get the idea. It's the how that connects your code to the real world.
All right, so if the provider is the how, the resource is the what. A resource block is where you declare an actual piece of infrastructure. You want an AWS EC2 server? Boom, you write an AWS instance resource. Need a Docker container? You write a Docker container resource. This is the heart of Terraform. You just state what you want to exist, and Terraform figures out how to make it happen.
Now, this next part is where the real magic happens. It's the concept of state. This is basically Terraform's memory. The state file is just a map of your code to the actual infrastructure it created. Without it, Terraform would have no clue what it's managing. And this is the key takeaway, right? This file becomes the single source of truth for your entire infrastructure. Okay, you've got the basics down, that's great. But what happens when your infrastructure gets bigger, or when you need to start working with a team? Let's move on and see how this actually scales. This next part is all about making your code reusable and safe for collaboration.
In the software world, there's this golden rule. Don't repeat yourself, or DRY for short. If you find yourself copying and pasting the same chunk of code to create, say, 10 different web servers, you're making your life way harder than it needs to be. There's a much smarter way to go about it.
So what is that smarter way? Well, it's modules. Think of a module as a reusable, shareable package of Terraform code. You can define your perfect, super secure web server configuration once inside a module, and then call that module dozens of times with just slight variations. This is absolutely non-negotiable for managing infrastructure at any real scale. But this brings up a really critical question. If you and a teammate both try to change the same piece of infrastructure at the exact same time, using that state file we talked about, well, who wins, right? It's a total recipe for disaster.
The solution is something called remote state. Look, keeping that state file on your own laptop is fine for a solo project, but for teams, it's a huge, huge risk. By storing the state in a shared remote place like Terraform Cloud, you get this crucial feature, state locking. When you run a command, the state gets locked, preventing anyone else from making conflicting changes until you're done.
With a solid foundation under our belts and a strategy for working together, it's time to apply these skills to the real world. Let's take a look at how Terraform goes from these simple tests to commanding entire cloud environments. You know, the really beautiful thing about Terraform is that the same principles apply everywhere. The workflow you use to just spin up a quick Docker container on your laptop for testing is the exact same workflow you'll use to provision a massive, global, multi-region architecture in AWS.
And this automation can handle some seriously complex tasks. I mean, we're talking about building entire secure networks, VPCs as they're called, completely from scratch, or creating users with the exact permissions they need, and nothing more. You're managing the complete lifecycle of virtual servers, from creation all the way to termination, all with code. But here's where it gets really powerful.
Terraform isn't just for one cloud provider. It was designed from day one to be multi-cloud. It's one tool, one language to manage your infrastructure on AWS, Google Cloud, Azure, and honestly, hundreds of other services.
And this table just shows you how brilliantly simple it is. In the very same set of files, you can define your AWS provider, your Google Cloud provider, and your Azure provider. Terraform keeps all their authentication separate and allows you to build resources across all three platforms at the same time. It's incredible.
We've built reusable code, and we've deployed it to the cloud. The final step is to remove the human element as much as we possibly can and achieve true professional-grade automation.
So the real mental shift you have to make is this. Your infrastructure code is just as critical as your application code, period. It needs version control, it needs testing, it needs peer review, and it absolutely needs an automated deployment pipeline. And this is what that looks like in practice, a workflow called GitOps. A developer pushes a code change to Git, a pipeline automatically kicks off and runs Terraform Plan to generate a preview of the changes for review. Once someone looks at it and gives it the thumbs up, the pipeline runs Terraform Apply to deploy those changes for real. It's safe, auditable, and completely automated.
And that pipeline should be packed with safety checks. Before anything gets applied, you run a series of commands. Terraform Validate checks for syntax errors. Terraform FMT-check makes sure the formatting is consistent. And of course, Terraform Plan gives you that final preview. Think of these as your quality gates.
Whew! We've covered a ton of ground, haven't we? From the basic building blocks all the way to fully automated multi-cloud deployments. So let's bring it all together with a simple blueprint for success.
These are the absolute non-negotiables for using Terraform in production. Everything is in Git. Always use a remote backend with state locking. Build with reusable modules. Tag everything so you know what it costs and who owns it. Never, ever, ever commit credentials. And finally, always require another human to review the plan output before you apply it.
This isn't just another tool. It's a whole new way of thinking about infrastructure. It gives you the power to define, to share, and to evolve your cloud architecture with the same safety and speed we expect from modern software. So the real question is, with this blueprint in your hands, what will you build?